Hey everyone, so today we are going to learn motion and now you have motion in all kinds of directions, so not in one dimension or one direction, in all directions. Okay, you can have motions. Questions will be coming from all directions. Let's just get started. So first you need to know the term motion. So what is this? This is a change in the position of an object with respect to its surroundings and its time. Okay, so how an object is changing with its surroundings and time. Suppose you are going, suppose there's a train, there's a person, suppose, and he is going from A position to B position. Okay, and time taken is here is C. Here is one. Here he was in 0 seconds, and here he is in 1 second. So, in respect to time, he is changing his position, and that is known as motion. Can I make it clear to you? If you have any more doubts regarding motion, write down in the comments. Translatory motion, the motion of an object in which every point on the object moves to the same distance in the same interval of time. So, how much if the distance is 1 meter, then the time would also be 1 second. 2 meters distance, 2 second time, like this. Okay, 3 meter distance, 3 second time. Okay, so each time motion is confined to a same place. This is known as transitory motion. Now, what is rectilinear motion? Motion of a body along a straight line. So, if the motion is along a straight line, as you can see in the above figure, A and B, you will have rectilinear motion. Curvilinear motion, if a motion is in a curved line, suppose this is this point A and point B. So you have a curve over here. So that will be known as curvilinear motion. Then you have circulatory motion, a motion around which a fixed point is revolved on a circular path. Now I'll say you just a moment. Suppose you have a string tied to this knot, and then you have a string over here. You have a stone over here, and the stone rotates all its way to come here. Again, it is revolving around a fixed point, and that is known as the circulatory motion. Rotatory motion, the motion of a body which moves or spins along its fixed axis. Suppose you have a fixed axis, take and consider our Earth, and then you have a circular body. Okay, you have a body moving around it, around this axis. Okay, consider our Earth, our rotation of the Earth. And then oscillatory motion, the back and forth movement of a body about its mean position. Consider a pendulum. You have a string. You have a string tied to a knot, and then you have a bob over here, and then you move, you oscillate. You go, once you go here, again you come back over here, again you go to here, this position, again here, again here, again here, like this you come back, okay? Next, you have the vibratory motion, a type of oscillatory motion where the body moves back and forth about its mean position. So, the mean position in the pendulum, what was happening? In a pendulum, this is the mean position is changing, right? Changing, right? And in vibratory motion, the mean position is not changing. It's going like this abruptly. It's not changing, okay? Periodic motion, the motion which gets repeated after a regular interval of time. Okay, so a motion which gets repeated, it is getting repeated after a regular interval of time. Suppose 24 hours in a, there's 24 hours in a whole day, and 12 hours there is the sun, and 12 hours there is not the sun, right? 12 hours there is the sun, again after 12 hours the sun is again coming out, again after 12 hours the sun is setting, again it's rising, again setting, like this. It's a periodic motion. Non-periodic motion, the motion which does not repeat itself after regular intervals of time. Suppose consider the growth and death of an organism. No, it's not repetitive also. Wait. Non-periodic motion, consider the Okay, non-periodic motion, just consider the tides which are coming. They're coming at different interval of time. Right, once they come in the evening, once they come in the morning. Okay, so non-periodic motion is this. Or a motion of a pendulum clock which is destructured, which is contracting and expanding, is known as a non-periodic motion. It does not repeat itself in time. Multiple motion, when a body has has more than one time motion, is known as multiple motion. Just a minute. Okay, so then what is a multiple motion? A body which is having more than one motion at a time. It's having rectilinear motion, simultaneously it's also having periodic motion. Suppose a car which is moving with the same velocity or the same speed, if you are not familiar with velocity. Okay, the car which is moving in the same speed will have multiple motion. Rolling motion, a stone rolling down the hill is having rolling motion. It's having both rotatory as well as translatory motion. Think about the definitions and think about the definition of the rolling motion. You will get it. Random motion, when a body moves such that it has no fixed path and has its motion changed suddenly from one type to another. Okay, so what is the difference between this random and multiple motion? In multiple motions, both motions at the same time, but in random motion, there is only one motion at one time and the other motion at the other time. Uniform motion, when a moving body covers equal distance and equal intervals of time. Okay, in non-uniform motion, when a moving body covers unequal distances in equal intervals of time or equal distances in unequal intervals of time. Means any one is unequal, you get non-uniform motion. When you get both equal, then you get an uniform motion. Next is average speed, the ratio of the total distance covered by the object to the total time taken during the journey. So, you have learnt it in maths that average speed is equal to total distance by total time. So this only we are doing the ratio of the total distance covered by the total time taken in the journey. Okay, mass, the quantity of matter contained in an object. Okay, you have learned it in chemistry. Weight, the force by which the earth attracts the body towards its center. Okay, weight can be changed, but mass it cannot be changed. Okay, because weight is due to g, gravitation, and mass is not due to g. Okay, now, a body is said to be at rest if it does not change its position when with respect to its intermediate surroundings. Suppose a person who is okay. Let me read the second point also. A body is said to be in motion if it changes its position with respect to its intermediate surroundings. So, suppose a person sitting in the train will see the person in the platform moving. Is that person moving? No, but the person is moving with respect to the person sitting in the train, and will see the person sitting next to him in rest. The person is moving because the train is also moving, right? But with respect to him, the person is in rest. So everything is in respect to with everything. So different types of motion are translatory motion, which are rectilinear and curvilinear motion, rotatory motion, oscillatory motion, periodic motion, non-periodic motion, multiple motion, random motion, rolling motion, uniform and non-uniform motion. All these definitions are explained to you, okay, in the prior of this chapter. The distance covered by a body in unit time is known as the speed of the body. So speed equal to distance by time. And what is the SI unit? Meter per second square. In the non-uniform motion, the average speed of the body is calculated as the ratio of the total distance travelled by an object to the total time taken during the journey. So in a non-uniform speed, always the average speed is calculated, because how will you get the certain speed? Because every time it's changing its speed, right? How will you get it? Either it is changing distance or it is changing time. The speed is also changing, right? So, if, like I'm saying, if S equal to d by t, and if d is changed or t is changed, you will get varied results, right? Therefore, it's always we have to calculate the average speed. We cannot calculate the accurate speed. Okay, if a body covers equal distances in equal intervals of time, but the direction is not constant, then also the motion is considered to be non-uniform. Yeah, because always it is uh, categorized to a vector quantity which is velocity. Speed's vector quantity is velocity. Okay, so if it's not, the direction is not constant, and it's non-uniform. Now the SI unit of mass is kg and weight is Newton. Okay, force unit Newton. Okay, and weight unit is also Newton. Now infographs. Now what's a rotatory motion? Now see, the examples over here are open to you all. You can get access of it. A fan that is rotating in your ceiling, okay, is a rotatory motion. So if a body moves or spins across this axis, just see it about its fixed axis, because without changing the radius of the motion. Radius is same, right? If this blade goes here also, the blade will not gain any kind of length, right? So radius will be same, and therefore it is a rotatory motion. Rolling motion, the body inhibits both rotatory as well as translatory motion. The motion is called rolling motion. The movement of a scooter, car, bicycle wheel, the movement of a ball on the ground, and the motion of a drill are examples of rolling motion. Now see very carefully. Over here you get the road in which you may use to drill your walls, etc. You see it is rotating in a very high speed, okay, and it's going in a straight path also. So it possesses translatory motion as well as rolling motion. Okay, see it's rolling, right? So that's sorry, it's as well as rotating motion. I'm sorry, just a minute. Now, simple pendulum. An arrangement that consists of a small heavy mass suspended by a light and flexible string from this ridge support is known as a simple pendulum. Now, please mark it. It's a rigid support over here, the string over there, and here you have the bob, the extreme position, and the mean position. Now, multiple motion is the motion of the earth. The earth keeps on rotating on its axis as well as revolving around the sun in a curved path in this interval. Okay, so it's multiple motion. It is as well as rotating as well as it is revolving. Best example of multiple motion. See, vehicles moving on a straight road, they are having linear motion as well as their wheels rotate in circulatory motion. So it's multiple motion. Also, while cycling, the tires of the cycle rotate, but the cycle moves in a forward linear direction. C. Now drawing water from a whale. In a whale, the pulley of the rope runs exhibit to circular motion and the bucket shows linear motion. Now oscillatory motion, when a body as a whole moves forth and back about its mean position, is described as oscillatory motion. Okay. Translatory motion, a body is said to be a linear or translatory motion if it moves in a line in such a way that every part moves through the same distance in the same intervals of time. When it is to move same distance and same interval of time, then it's only a translatory motion. Now there are two types: rectilinear and curvilinear motion. Now circulatory motion, the object is said to be a circulatory or circular motion if it moves around a fixed point in a circular path. It is a fixed type of curvilinear motion. Okay, so it's moving as a curve, and so it's considered one of the curvilinear motions in which the distance of a moving object from a fixed point remain constant. So the moving object, the distance from a moving object is remaining fixed. Okay, and it's constant. So it's the circulatory motion or the circular motion. Okay, so here we complete our chapter. Thank you so much. Goodbye.